Hey guys, welcome to this full stack development video. This full course video will cover various technologies used in application development. The video will go in depth for each tool and framework in the roadmap to become a successful full stack developer. But before we begin, if you haven't subscribed to our channel already, make sure to hit the subscribe button and the bell icon to never miss an update. So here's what we'll be covering in this session. First, we'll look at a simple introduction to what exactly full stack development is. Then, we'll learn the most popularly used version control system, that is Git, which helps you manage your project files. Next, we'll look at a tutorial on the commonly used front-end framework, that is Angular. Moving on, we'll understand back-end development and learn about Node.js. Talking about database management systems, we'll look at tutorials on MongoDB and MySQL. Now after this, we'll look at an Angular tutorial on how to build an admin dashboard. Moving further ahead, we'll have a section covering Maven and Jenkins. Finally, coming to testing tools, we'll learn the working of Selenium. And lastly, we'll conclude the session by understanding the popularly used continuous integration and continuous development tool, Docker. I hope you're excited for this video, so let's jump right in. So now what exactly is front-end? Every time you open a website, it has several UI components. And once you click on a particular icon, say sign in this case, you get navigated to the sign in or the login page, right? So what happens is that all of these items facilitate navigation and utility. These are collectively called as the front end. So the front end is the visible part of the website or the web application which is responsible for user experience. The user directly interacts with the front-end portion of the website or the web application. So now let's have a look at some of the front-end languages. So I'm sure you've heard of HTML, CSS and JavaScript. So these are collectively called the front-end languages. When it comes to HTML, it defines the structure of websites and formats the web pages. It also defines text documentation. So let's look at a simple example. So here I've made use of the h1 tag, which is the heading tag in HTML, and I've displayed the message hello welcome. So correspondingly, my website displays the same message. So HTML is responsible or defines what is being shown on the website. Next up is CSS. Now CSS is a style sheet that allows you to alter and style different web components, be it size, font, spacing, etc. It makes the content on the website look more decorative, correct? So now, if you have a look at the code here, I've added some styling. I've changed the font style to italic. I've made the text bold and I've changed the color to red. And again, correspondingly, all the changes are seen on the website. Moving on, we have JavaScript. Now, JavaScript is a very powerful client-side scripting language and it is mainly used for enhancing the interaction of a user with the web page. So again, if you have a look at the code here, I've created a form wherein the user can enter their name. And I've also displayed the message, please enter your name. As a result, an input box is made available where the user can type in their name. Now this is facilitated by JavaScript. So as I mentioned earlier, it is used to make web pages interactive and bring the web applications to life. So next, let's have a look at some front-end frameworks and libraries. Now most of these are JavaScript frameworks and libraries. First, we have React, then there's Angular, there's Vue, there's jQuery, and then there's Bootstrap. Now, all of these help develop the front end of the application. However, when it comes to React, Angular, and Vue, it's not necessary that you must know everything to create a website. One of them will be sufficient. However, the usage of React is on the rise, and most of the developers prefer using React. jQuery and Bootstrap are also powerful frameworks that can be used to create interactive web pages. Now that you know what front-end development is, you must be wondering how the data is being fetched and how this data is being presented in front of you on your screen, correct? Now this is all facilitated by the back-end of the application. So let's understand what back-end development is. Now back-end basically refers to the server-side development of the application. It is responsible for managing all the database, with the help of queries and APIs. So every time the user makes a request, it queries the database and retrieves the data from the database and presents it to the user. And lastly, it ensures data consistency. So now let's have a look at some backend languages and frameworks. Firstly, we have Node. Node and Express.js are packages provided by JavaScript. Then there's Python, which is a very popularly used language. Python frameworks like Django and Flask are popularly used to create the backend of applications. Then there's Java, and Java provides Spring and Java Server Faces, which are also used for backend development. Then there's C#, which provides frameworks like ASP.NET Core and ASP.NET MVC. And other popularly used backend languages are PHP, there's Perl, and Ruby. Database is the collection of interrelated data which helps in efficient retrieval, insertion, and deletion of data from database and organizes the data in the form of tables, views, schemas, reports. Now, some of the commonly used database management systems are MySQL, there's PostgreSQL, there's Microsoft SQL Server, there's Oracle Database, and then there's MongoDB.
Today, I'm going to cover a few essential Git commands and walk you through a demonstration for most of it. I begin by installing a Git bash or the Git client and configuring it for its first time usage. Once I'm done with configuring the Git client, I'm going to spin up few repositories locally and work on these repositories using Git commands. Once I'm happy with my local changes, I'm going to commit few of them and then push these changes to a Git server of my choice. For today's demonstration, I plan to use github.com, which is a cloud-hosted free service, and it provides free account registrations for anyone. Eventually, I will cover a few topics regarding Git branching and merging, because these two, in my opinion, are the killer features of the Git distributed version control tool. Git is one of the most popular distributed version control tools of recent times, and like any other distributed version control tool, it allows us to perform various version control tasks without really needing a network connection. Before I jump into my demonstration, let me spend some time explaining to you the Git client-server working model. What does it take for a couple of users to collaborate and start working with Git? The bare minimal thing that any user would need in order to start working with Git is something called as Git bash or the Git client. This comes as an installer for all popular operating systems like Windows, all flavors of Windows, Linux, macOS, and other operating systems. So once you install Git bash, you get a command line utility using which you can fire up your Git commands and ensure that you can bring up repositories. You can work with these repositories by adding files to it, committing changes to it, and all those Git commands would work perfectly well. So you can bring up a small repository and you can work with your repository using this Git bash. But what does it take for you to share this repository with another user who has also got Git bash installed on his system? This is where you would need something called as a Git server. So for user one or one user to share his repository with another user, he would need to collaborate using something called as a Git server. So in the present market, there are a bunch of Git servers which are popularly available. Some of them are free. Some of them come with a cost because they are licensed. A bunch of these servers that I can think of are GitHub, which is one of the most popular Git servers that is around in the market for a long time now. It comes with two variants. One is the cloud hosted one, which is the github.com. And then the other one is an enterprise server, which comes as a black box that can be installed into your data centers. So typically organizations who don't want their source code to be put up on the cloud would go for this GitHub enterprise servers, wherein they buy these servers and these servers are hosted on their data centers. Other popular variant of the Git server is Bitbucket. This is from the famous Atlassian products and it integrates very well with all other Atlassian products like Jira. In recent times, there's one other variant of the Git server called GitLab, which is getting very, very popular these days because GitLab not just provides a Git server, it also provides something called as a runner. This is a part of the continuous integration strategy where as soon as you have a source code check-in that is going in, you have this runner that kicks up and builds your particular project. So all these are bundled together in a GitLab. and GitLab also provides you with a community edition which is almost free of cost. Having said that, there are a bunch of these tools available. For my demonstration, what I'm going to do is I've already registered myself on the github.com by providing my username and my password. And I'm going to use a free account. So whatever repositories that I'm going to put up on this server is all public by default. So I've already registered myself by using my username or my email ID and my password. So this set of authentication is also referred to as HTTPS authentication. So in order for me to share my repository with say user2, the first thing that I got to do is have an access to a Git server where both user1 and user2 are set up. So once I have that, I can push my repository onto this server and provide right kind of access so that user2 or the other developer who wishes to collaborate with me on this repository can use his credentials. As long as he's registered properly on the Git server, he can use his credentials and pull down this repository and work with this repository. So this is the HTTPS way of authenticating and sharing repositories. Another popular way of sharing repositories or working with each other is called as SSH authentication. As many of you would know, SSH means nothing but creation of a private and a public key. A bunch of keys, public and private, are created on the client machine. While I create keys, I will be asked for a passphrase. I need to type in a passphrase and remember my passphrase. And then I take this public key and kind of post it onto my account within my Git server, so that whenever I'm going to connect next time using my command prompt or any of the tools, it's going to challenge me for my passphrase. As long as I remember my passphrase correctly, I can authenticate myself and get into the server. So both HTTPS and SSH are popular ways of communicating with the Git server. Having said this, let me just get started by installing the Git bash on my local system and then fire up some of these Git commands and build up some repositories, make some changes in my repository, commit these changes, and later use my GitHub credential to connect to my GitHub server and push my repositories out there. Let me now go ahead and find my Git bash for my Windows so that I can go ahead and install it. So I just type in Git client for Windows, open up a browser and type in for this. The first one that I find is a GUI tool. I don't need this GUI client, I need this one. So this is the Git client or the Git bash that I was referring to. It's about 40 megs, and let me just download this. Pause this video for some time so that the download happens and come back to you once I have the download. The download seems to be complete. When I'm recording this video, the version that I have, the latest version that is there is 2.19.0, and this is a 64-bit version for Windows. So I've got that downloaded. Let me go ahead and find it and install this exe. Alright, I go ahead choosing all the default options. I want it to be installed in C: program files under the Git folder. Everything looks good for me. I'm not going to make any changes here. Git bash from Windows. Yes, I may want to use git from Windows command prompt. That sounds good for me. OpenSSH, that's fine. Looks good. Looks good. No, I don't want any of these new features. So what I'm doing is installing the Git bash or the Git client so that I can start using my Git commands. And the version that I'm using is 2.19.0, which as I record this video, this happens to be the latest version. Alright, so looks good. I don't want to see the release notes. I'll say launch Git bash. So what I get is this window. So this is the Git command prompt. So let me check if everything is looking good. Say Git version, it sounds good. Say Git help. Alright, a lot of Git help commands. Everything looks good. So I ended up installing the Git bash. I can go ahead with all other commands. Now that I have Git bash installed on my system, let me open up a Git bash prompt and start using it. But before I do anything, I just need to configure it for the first time, stating what would be the username and the email ID with which I want the Git bash to be configured with. The command to do that is git config -- global, which means that this setting that I'm going to set would be a global setting. User.name, and this the name of the user would need to be specified within a double quote. In my case, I am using a Simplilearn account, which is the official account, and this is the particular username of this account. The other setting is nothing but git config -- global. This is also a global setting, and this would be the email ID. The email ID need not contain a double quote. So in my case, this is the email ID that I would be setting up Git to work with. All right, let me check if the configurations were set correctly or not. All right, if you see this, the username and the email ID has been picked up the way I wanted it to be picked up. Looks good so far. All right, so what do we do next? By default, whenever you open up the Git prompt, you're placed into your home directory. Let me create a folder here, which would be a repository folder from where I'm going to create all my multiple Git repositories. So I will create a folder called, let's say, git_demo. All right, there's already a folder called git demo. So let me just delete it in the first place and let me create this git demo again. All right, let me navigate to this particular folder. So this is the folder. Let me open up that folder using a command prompt. This is my git demo. So this would be a folder. So I would use this folder as a base folder for creating all other repositories as a part of this demo. So let me create my first repository. A repository is nothing but a folder. So let me create my first folder called first repo. And let me get into this repo. All right, as of now, this is just an empty folder. If at all I navigate to this, you would see that this folder is empty. There's nothing much in this folder at all at this moment. Okay, so let me create a repository out of this. How do I create a repository of this? It's pretty simple. I just run a git init command. When I say git init, it means it's going to initialize a repository. As of now, the folder contained nothing in it. It was an empty repository. So it initializes an empty repository in this particular folder. If at all I look at my content, you would see that there's a hidden folder. This would be a hidden folder since I've configured my Explorer to view all hidden folders. I see it, otherwise you wouldn't see it. So a folder by name .git is created within this first repo. And this was created because we ran the command git init. If I get into this folder, I see a bunch of directories and other configurations. If you see, there's something called as a hooks directory, a couple of configuration files that are here in this directory. All these relate to one or the other type of a client hook that can be enabled. And there's info, there's objects, there's references, a bunch of stuff that is there. So what is this folder? This is a magical Git folder, and this is created whenever a repository is initialized. So by default, if at all you get into any Git folder or any Git repository, you would see this .git folder. A word of caution, do not get into this folder and try to modify anything, because if you fiddle around with this and corrupt this particular folder, your whole repository will go for a toss. So let me come out of this and let me show you another thing. Now, if you notice here, when I was in the folder, the repository did not have anything after this. Now, when I say git init, there is something called as a master that shows up. So typically what happens is whenever a Git repository is created for the first time, it creates a default branch. The name of the branch is called master. And that is why you would see master within braces. This doesn't mean anything else other than we have a repository out in this particular folder. And by default, there is a branch called master, and we are currently on that branch. If at all I create multiple branches in this folder, whenever I navigate to different branches, the branch name within these brackets would change. All right, so far so good. So we created a folder, we made it a Git repository by initializing that with a git init, and then I've not put anything yet in the repository. So let me try to do that. Let me create a few files within this particular repository. So I use a touch command. Touch is a Linux command. It kind of creates this particular folder. If at all you're not comfortable with the file creation by this way, you can always use a file explorer and create some files in this. So I create a file called touchmaster.txt. I'll open up in the notepad. Okay, so this is my first file. That's what I'm going to write inside this. I save this and I come out of this. All right, now let me do a git status command. So what does this tell you? There's no commit set, you're on the master branch, there is an untracked file, and this shows up in red. It also gives you all the commands that is supposed to be run. So if at all you want to add this file, you would say git add and the name of the file, and then you're going to commit it. So what happened is that when the repository was initialized, it was an empty repository. Now that a git notices that there is a new file in this repository called master.txt. If at all you want us to let git know that you want to track this file, we need to add this to the repository. So the command to add that is called git add. I can specify either the name of the file or I can give a wild character saying git add dot. Now if I run the git status command again, it says there's no commits yet. Added a file, and the file which was earlier in red now shows up in green, and it says it's a new file, master.txt. All right, it also gives you something called git remove command if at all you want to unstage or undo your changes. So what has happened is the file which was earlier untracked is been added into the git index, or it is ready for staging, or it's in a staged state. Now I can go ahead and commit this file if at all that's what I want to do. So let me do that. I'll do a git commit -m and I give a message that I want. I would say this is my first git commit. All right, I run the git status command again and see it says on the branch master, nothing to commit. It's all nice and clean. So typically what happened was I created an empty directory, made it into a git folder by doing a git init. I put a file into it. I made some changes to the file. I added that file into the repository and I committed to the repository. If at all I run the git log command, it says this was the commit ID or the commit number or the commit hashtag, and this is the author. If you notice, this is the email ID and the username that we set earlier. And this was done on this date, and this is the commit message that is there. All of it looks so good. Let me do one more commit into this repository. So I will touch master1.txt. I'll put in another file. I'll open up this particular file, write something into this. All right, I save this change. Let me also open up the older file, make some more change into this. All right, so what I did, I modified the older file that existed. I also added a new file to my repository. Now, if I run the git status command, it says modified this file, which is showing in red, and it says you have one more file, which was an untracked file. All right, now let me add both these files because these are the changes that I want to incorporate. I would say git add dot. I run the git status command again, and it says now this is a modified file, this is a new file. Looks good to me. Let me go ahead and commit this. So git commit with a message that says this is my second commit. All right, if I do a git log now, it shows both the commits. The first commit is the one that shows up at the bottom, and the topmost one is the latest commit that is there. So far, so good. If at all you notice, I'm doing all these git commands without really connecting it to any git server. I don't need any network connection for doing any of these things. I can keep on doing more and more git commands and run git commands the way I want to without really having any connections to the git server. Now that I have my changes the way I wanted, and I've checked in all the code changes into my local repository, I may want to share my repository with somebody else and work in a collaborative way. So the way to do that is, as I mentioned earlier, to host this repository or to push this repository onto a Git server. I already have a GitHub account wherein I've registered myself using my username and password. So I'll log into my GitHub account using my username and credentials, and let me go ahead and create a new repository. My repository is already there on the local system, so what I essentially need is just a placeholder for my repository so that I can link them together and push the content from my local repository to the server. If you notice, the name of my repository is this first repo. So let me copy this. I would create a folder structure or a repository structure on the server with the same name, so that when I pushed my repository from my local box, it will go ahead and get created in the server. So the repository name should be the same as what I created on my local box. Description, I would say this is my first GitHub repository on the server. This is just an optional description that will show up. And if you notice, I can't have any private repositories. So whatever repositories that I'm going to create here would be a public repository. So I choose public, and I don't want to initialize this with a README file or anything of that, because I already have a repository with some content, with some code checked in. All that I need is a placeholder for my repository on the server. So with this option, with just the name and with an optional description and the repository being public, I go ahead and click on the Create Repository button. So if you notice, it gives me a bunch of commands that I would need to run in order to create a repository and push it onto the server. And also, important point, it shows me two URLs. One is the HTTPS URL and the other one is the SSH URL. As of now, we do not have any SSH keys that is set up. So let me use this HTTPS URL to connect my local repository with the repository on the server. So I've done all these things. I already have the repository set up. All that I need is a placeholder for me to connect my local repository with the server URL. So this would be the command that I need to copy, which essentially links or adds an origin with the URL of the Git server. I just copy this command and run it here. Git remote add. The name of the remote is called origin, and it points to an HTTPS URL, which is nothing but the placeholder that I've created on the server. All right, so let me check if it's added correctly. Okay, the URL looks good. I'm all set. I've got 2 commits in my repository. I'm done with all the changes. So let me try to push my repository onto the server. The command for doing it for the first time is git push -u. This is for linking the upstream origin master. So git push -u upstream linking origin master, link the master branch of my local repository with the master branch on the server repository. And where is it going to push? It is going to push by default to an origin, and the origin points to this URL. All right, let me try doing this. So it essentially opens up an URL asking me the credentials with which I need to log into my GitHub server. So let me just copy and paste the username and the password with which I have registered. I would say login. Okay, success. So I'm able to create a repository on the server, and the content seems to be pushed, and it created a new branch called master. It has linked the master branch from the local repository with the master branch on the server. So let me go back to my server and refresh this page and see if all my commits have come in. master1.txt. If at all I see the commits, there seem to be 2 commits. This is my first commit, this is my second commit. And if at all you notice, each of this commit comes with a hash key or a hash ID, which contains the details of my commits. In this commit, the files were added. This was the line that was added. If you look at the second commit, I added these lines. I made this, one line chain that was there. I also added this new file, which was not existing. These are the 2 commits that existed. And if you see the timestamp of the commit, this is the commit which was committed 15 minutes ago. So what does this mean is that the commit is the timestamp when we actually committed the code in the client. The pushing is just after we have committed the change, we have pushed it. So there's no timestamp of the push that happened. This completes the first part of the tutorial, wherein I created a repository on the client and then I pushed it to the server after creating a repository skeleton on the server. Now let me demonstrate to you the SSH configuration that is required for creating a pair of SSH keys and ensuring that I connect to the GitHub server using the SSH mechanism. So for doing that, I need to first create a pair of private and public key. The command to do that is SSH keygen -t. I will use the RSA mechanism for creating my keys, capital C, and I need to specify the email ID using which I'm going to connect to, or I need to create the keys for. Alright, so generating a private and public key pair, it says, let me know what folder should I create the keys in. So by default, the keys are created in the user home directory under a .ssh folder. So this is pretty good for me. So let me go ahead and say that, that's fine. Enter a passphrase. So let me enter some passphrase. Keep in mind that I would need to remember my passphrase because when I'm going to authenticate myself using SSH mechanism, it will challenge me for this particular passphrase. I need to enter the right passphrase so that I get authenticated. So the key is generated and by default it is created in this particular folder. So let me go over to that particular folder. And this is the folder where the keys is generated. You would see a public key and a private key that is created. Let me open up the public key with a notepad and then copy the contents of the whole file. And now I would need to stick it in on the server so that I can get myself authenticated using SSH keys. So I've logged in to GitHub using my credentials and go to my settings. And you would see an SSH and GPG keys. Let me click on that. As of now, there are no SSH key or GPG keys. So I would click on new SSH key and let me paste my public key that I've copied. And I would say add SSH key. It prompts me for my password just to make sure that I've got the right kind of authentication to be adding a new key. So this one looks good. That means the keys were added successfully. Let me check if my SSH keys are working well. So I do SSH -T. I would say git at github.com. This is just to double check if my SSH keys are authenticated correctly. Are you sure you want a connection? Yes. You want to continue? Yes. All right. Now a check for my passphrase. Let me enter my passphrase. I hope I remember it correctly. All right. Pretty good. I've been successfully authenticated. So that means now my SSH keys are good. And just by using my passphrase, I can connect to my GitHub server using SSH. All right. So for the second use case, what I would do is create a repository on the server with some content in it and then clone that repository. Cloning is nothing but making a copy of that repository, linking the origin so that I create an exact replica of the repository which is there on the server on my local drive. So let me first create a repository on the server. I will create a new repository. Let me give a name for my repository and let me kind of initialize that with a README file. I would call this my second repo. Give some description. This is my second repo that is created straight on the Git server, on the GitHub server to be precise. It's a public repository. This time I'm going to choose this option. The reason being that I don't want to create just a skeleton as of now. I want to create a repository with some README file in it. A random README file with no content in it, but then I want a repository to be created on the server. All right, I say create a repository. So a random README file with some content in it gets created and I can see there are two URLs to this repository, HTTPS and SSH. So this time, let me copy the SSH URL so that I will use this URL to clone this repository on the server, rather from the server to my local box. All right, so let me navigate to my root folder, the folder that I created for making all my repositories, Git repositories. If you see, my first repository is already here. So let me clone my repository, the second repo that I created on the server. The command to do that is git clone the URL of the repository that I want to clone. Oops, Looks like I didn't copy the URL correctly. Let me copy that again. Copy this URL. All right. So if you notice, there is no HTTPS to it. I'm just cloning the URL, that is SSH URL of the repository. It asks for my passphrase again. Okay. So I just had first repository earlier. Now I have something called a second repo. This is an exact replica of whatever was the repository content that was created on the server. So if I get into the repository, there's just a simple readme file that is there. Let me try to add a new file out here. I would say notepad, second.txt, some text file I'm going to put in here. Yes, definitely you will not find that file there. This is my second file that I will push onto the server. I'm going to put in some content out there. I'm going to save this. And if I do git status, it says this is a new untracked file. Do you want to add this file onto the repository? Do you want to track this file? Yes, I definitely want to track this file. Let me also commit my change to the file with a message. This is my first commit for the second repo. I give in some particular message. And this time around, since I cloned my repository from a server, the origin is already set for me. I don't really need to add the origin and all that stuff, because what happened in the first case was that I was creating a repository from my local box and then pushing it on the server, which is why I had to set up the upstream branches and stuff like that. In this case, I have cloned an existing repository from the server. So when I clone, I get the replica along with all references to my repository. So I don't need to do anything more other than push the content. I would just say git push. To be on the safer side, I would say origin and master. It asks me for the passphrase. Okay, it pushed the content onto the server. Let me see if the contents have come in here. Okay, wonderful. I had only one commit. Now I see my second commit. So what was added as a part of the second commit? It says a new file was added. All this line that never existed got added. This is the second file, the content exactly what I pushed onto the server. Now this completes the tutorial wherein I created a repository on the server, cloned it, made some changes to the repository and pushed it to the server using SSH. A quick recap of all the git commands that we ran till now. Git init is used to initialize a repository. So if at all you're creating a local repository, you can get into any of the folder which is not a git repository and run this command. Whenever you run this command, a magical folder by name .git gets created in the folder, and from that time onwards, Git will start tracking any changes that happen to that particular folder. It also creates a new repository and a branch. By default, the branch that is created is called the master branch. Git add dot is a wildcard character for adding any number of new files into your Git repository. If you have a bunch of files, 1 file, 2 file, 10 files, a folder containing multiple files in it, all of them could be added into the repository using this command. So once you add any number of files into the repository, you can keep on adding more and more files into the repository. Once you're done with that, you want to commit the changes that has happened in the repository, you use the git commit command. Git commit -m with a meaningful message. This will commit all the work items that you've done in terms of the files that got changed, the files that got added, all this with one particular message. Git status will give you the status of all the files and folders, any file that got added, any file that got created, any file that was deleted. All the status of the files will be obtained using the git status command. Git log will show you all the commit history with the latest history or the latest commit showing up on top. Git add remote origin. This command is used whenever you want to link any local repository to a server. And this is when you want to really push a repository from the local to the server for the first time. Git push -u origin and master. This is the command that you would use whenever you want to push contents from the local repository to the server. Git clone and the URL of the server. This is the command that you would run whenever you have an existing repository on the server and you want to make a fresh clone or a fresh copy of that particular repository onto your local box. More than often, many developers or Git users find themselves in situations where they would want to go back in history and modify or change some of the files that they recently committed or checked into the repository. Now, from a perspective of Git, this is a very simple activity. However, from a perspective of version control tool, you will have to be really cautious about the change that you're going to do. In case the changes are pretty local, none of the developers or none of the other users who are collaborating with you would be affected by this change. You're good to go ahead and make this change. However, if your repository is being pushed to the server and you're trying to modify something from history, this would have a very bad or adverse effect on all the other users who will be using it. You need to be really cautious while running these commands. In case your repository contents are local, you've not pushed your changes to your repository, and if at all you made some changes to the repository, maybe to fix a defect or to include a new feature, and you missed few things, you can go ahead and modify this with some of these commands. Let's say I have this simple repository called undo repo, and if at all I look at the logs of these, I have the commit histories which are like this. I have about 5 commits that is there in my repository, and in C1 I've added a file, in C2 I've added another file, in C3 I've also added some file, in C4 I've made some changes to M1 and M3, and in C5 I've added another file called M4. Now this is my commit history. Now let's say I made these 2 commits, but possibly I want to club them together along with some other changes because whatever changes I did not really fix things the way I expected it to fix. So there is a git command called git reset. This would allow me to go back in history, to go back to any of the snapshot, get rid of all this commit history or the commit messages, but retain the changes that were made as a part of these commits. So if at all I need to go back in history and go back to this particular commit, and however I just want to get rid of these commits that are there in terms of the commit messages, but I want the changes that were there as a part of these commits to still exist, I would do command called git reset -- soft. Now this would go back or unwind my changes back to this particular snapshot, getting rid of all the commit messages that were there as a part of these 2 commits, but a soft would ensure that the file changes that were done as a part of these 2 commits would still exist or full remain. So the command for that is git reset -- soft, which is the snapshot that I want to get back to. If this is the commit that I want to get back to, I just copy this and I paste this. All right, it doesn't give me any message, but if at all I do a git log pretty one line, what it says is C1, C2, now the head, which is nothing but the current pointer, which was earlier pointing to C5, it's gone back to C3. Now what happened to the changes that were there as a part of C4 and C5? If at all you do a git status, if you see the changes that were a part of C4 was some changes to M1 and M2, and C5, a new file got M4 got added. If at all I do a git status, you would see those changes still exist. However, from the git history or the git commit history, C3 is the topmost commit that exists as of now. C4 and C5 have been gotten rid of, but the changes that were there still exist. All right, now I can make some more changes that I want if as a part of my commit and possibly go ahead and commit this whole thing as a new commit altogether. Maybe I'll open up a notepad and possibly create a new file called m6.txt and say one new file that was missed out. I make this change. I go to a git status. All these files are still there. I would say git add dot. I would say git commit -m C4 rewriting history, and I do a git log pretty. There you go. So C1, C2, C3 still existed, and whatever was a part of C4 and C5, the older ones, I've gotten rid of this along with those old changes. I also added a new file. I made some changes and I was able to commit it. Now, if you look at my Git history, it's all nice and clean. However, do this activity only when you don't push your Git repository to the server. One other most powerful and useful command while undoing or resetting the history is something called as revert. This is a safe way of undoing some things. Remember what I talked about when exactly you can do a reset? It's only when your changes are local and is not being pushed to the repository. Take this scenario wherein, let's say I have a Git server and I have the changes which are C1, C2, C3, and possibly C4. All right. So this is a bunch of commits that has happened. This was the oldest commit and this is the newest commit. And if at all developer 1 is the one who's responsible for pushing these contents in the first place. So he has got C1 to C4 on his history. I'm going to jump all these C2 and C3 and get into C4, and he's pushed all these contents out here. And there are a bunch of people from the server who has pulled this repository, and all of them are at the same level. Now imagine a use case where developer 1 then figures out that by mistake he put in the C3, which was the wrong thing to do, and possibly he could have done a better job of fixing this in a different way. So he wants to get rid of the C3 or C4 or any one of these commits. If he's going to do that and push it to the server, first of all, the Git server would not allow him to go back in history. But assuming that he forcibly pushed something, what would happen to all these people who are looking to work ahead from C4? All of them would be affected in an adverse way. So in short, never go back in history. If at all you need to undo something, go ahead and put in a new commit to undo something. Let's take this example. Maybe if at all a developer 1 wants to get rid of C3, better way to do that is by adding a new commit which is ahead, say let's say C5. And what does this commit do? This commit possibly gets rid of C3. Instead of going back in history, it actually is taking your Git history ahead. But as a part of this commit, you're undoing some part of the work that was done as a part of C3. In short, you're removing a commit, but to remove a commit, you're adding a new commit. And this is why you're doing it, because there are a bunch of other people who are using this repository collaboratively and who are planning to get ahead in terms of history. They cannot afford to go back in history and modify something in history. All right, the command to do this is called the git revert command. So let me take up this repository, which has got a bunch of commits in it. And if at all I do a git log, pretty one line, I have these bunch of commits. In C1, I've added a file. In C2, I've added another file. In C3, I've added one more file. And in C4, I made some changes. And this is the latest commit, and this is the oldest commit. So if at all I see the contents of the Git folder, it contains M1, M2, M3, and M4. And let's say, looking at the previous use case that I mentioned, I may want to get rid of this particular commit. I want to get rid of the C3, which is nothing but I've added a file called m3.txt, but I added it by mistake. I need a better way of fixing it. Possibly I'll look at it later on, but for now, I don't want this particular commit and the changes that were made as a part of that commit to exist. So the better way to do that is using the git revert command. So git revert and the commit ID, whatever I want to revert. So if I want to revert this, I copy this particular commit ID, and bear in mind that considering a reset, revert works on one commit at a time. So I can do one commit revert at a time. I can club a bunch of them together and do one commit, but otherwise the revert always works on one commit at a time. So git revert, paste this. Essentially what I'm trying to do, I'm trying to undo this particular commit. While I'm undoing this commit, what does git do? It safely adds a new commit, and a part of this new commit, it undoes whatever changes that were done as a part of this commit. So if I say git revert this, all right, I forgot to mention a message, which is why this window is showing up, but that message is good for me. I say write and quit. All right. And if I do a git log, all right, if you see this, C1 still is there in history, and our history is going ahead from C5. I see another commit, but what was there as a part of this commit actually is getting rid of this commit C3. So if at all I see my files here, there's only M1, M2 and M4. M3 was added as a part of C3. Now I've gotten rid of M3 by getting rid of the revert command for C3. So this is a better way of undoing things. Now that we have acquainted ourselves with few of those basic git commands, let me get into a very interesting topic regarding git, which is about branching. The topic is interesting because git deals with branches in a completely different way compared to any other version control tool. In most of the version control tools, whenever you create a new branch, a complete copy or a subset of the whole repository is created, which in my opinion is very cost inefficient because it is a very expensive operation, both in terms of time and the disk space. However, in Git, you just create a very lightweight movable pointer whenever you create a branch. There is no folder or no copy of the repository that is created. In short, the branches are very inexpensive in Git. So go ahead and create any number of branches that you need. However, once you create your branches, do all the work relating to that branch in that specific branch. And once you've completed your task, go ahead and merge your branches back into your base branch and then delete the branch. Let me go ahead and create a repository with some branches in this and give you a demonstration of that. So let me go back to my base directory, which is git demo, and then I'm going to create a new folder here. I'll create a folder called org details. All right, this is my folder here. All right, I navigate into this folder and let me create a repository here. I initialize a repository and .git folder is created without any files in it. So let me create a few files in it. Say notepad name.txt. Organization name. I create a name.txt within this. Maybe I'll create one more file in this. Notepad employees.txt. Simplilearn has over 3K employees. I just put in some content in this. Save this content. All right. So if at all I do git status, I just see two files in it. So let me go ahead and add these two files and let me commit my changes. So git commit -am or -m. First commit. So if I do a git log, I see only one commit and there are two files and you can see those two files that is here. All right. So at this stage, let me go ahead and create a new branch. And the command for creating a new branch is git branch name of the branch. So let me name my branch as Bangalore branch, BLR branch. And this created a branch. But I don't see any changes in the folder structure or in the file that exists here. I've just created this branch. So if at all I do a git branch, I see these two branches. And whatever star means I'm currently in this master branch. So let me go ahead and get into the BLR branch. At this moment, the number of files that exist in this repository is same. There's absolutely no change in any of the branches. Both master and BLR branch point to the same snapshot. So let me get into the other branch, and the command to do that is git checkout BLR branch. Now I actually switched into Bangalore branch. If you see the content of the files, there's exactly two files the way it was earlier, because I've created a branch from my base branch, which is the master branch. And when I created a branch, there were two files existing here. If you see the content of these files, they would all be the same. All right, so let me create a file that is specific to Bangalore branch. So I would just say Notepad. Maybe I want to put down the address of this organization specific to Bangalore in this address.txt. So I say Notepad address.txt. I'll say Simplilearn Bangalore office. Say located in some address. I would say Bangalore. That is the content of this file. And I'm creating all this new file in this BLR branch. So I would say git add dot, and I would say git commit -m Bangalore branch commit. All right. If you see this, now I have an address.txt which is there only in the Bangalore branch that I'm presently on. Now let me switch back to my master branch. The command to do that is git checkout master branch. If you remember, when I forked out or when I created a new branch from the master branch, I didn't have this address.txt in it. So let me go back to git checkout master branch and keep noticing this particular. What happened to the address.txt? It kind of disappeared. Now, how did that happen? It's all because of this magical git folder. So what happened is, now git knows that when you are in the master branch, the file that was there in the Bangalore branch, which was called the address.txt, didn't exist. So git is playing around with the file system snapshot. So if I come back, let's say I come back to git checkout Bangalore branch. If you see this, the address.txt file appears. So this particular file is only present in the branch, and git is playing around with the file system snapshot by moving the pointers across and ensuring that whenever I'm switching to Bangalore branch, I see this address.txt. When I go back to my master branch, I don't see this Bangalore branch contents, which is the address.txt. All right, now that I created this branch, maybe I may need to push this onto the server. So let me go ahead and create a particular repository structure on the server, similar to whatever we did in our previous exercise. So the name of the folder needs to be exactly this one. So let me copy this and let me create a repository very quickly. I'll go here and say new repository. All right, this is the name of the repository, git branch demo. This is what I'm going to put in as a description. I would say public. I don't want any readme files in it because I already have a repository. I would just say create a repository. All right, let me use the SSH URL. Yeah, this is the SSH URL. This is good for me. So let me copy this URL. Let me add it here. I'm linking my local repository with the server, and let me come back to my master branch. Let me first push my master branch. So I would say git push -u origin master. It asks for my passphrase. All right, I pushed my master branch. It looks good. It says new branch master is created. So if I go back to my server and I do a refresh, if you see, it says only one branch, and it says what is the name of the branch, master. If you see the contents, there is employees.txt and name.txt. Now let's try to push the other branch that is there. The command to do that is a little different compared to the way we created it on the client, because on the client we created the branch with a git branch command. Now this branch doesn't exist on the server, and I need to push this new branch onto the server. So the command would be git push -u origin and the name of the branch that I want to specifically push. All right, now it created a branch out here. Let me do a refresh of this. All right, it says 2 branches. If I get into this Bangalore branch, I would see the address.txt. If at all I go back into master branch, I would not see this address.txt. Wonderful. Now let me do one thing. Let me try to get the changes from the branch that I created back into the master branch. That is what I would mean by merging. I would want the changes that is there as a part of the Bangalore branch to come back into my master branch. So if I go to git checkout, Bangalore branch, I see this address.txt. This is there only as a part of Bangalore branch. Now, assuming that I'm done with the changes from the Bangalore branch, I want to get those changes back into my master. So let me come back to my master branch. And the way to merge in the changes is git merge. So what is it that you want to merge? I want to merge the Bangalore branch changes. And where will it merge? It will merge it into the current branch that I'm on. Presently, I'm in the master branch. So this command would merge the changes from the Bangalore branch into your master branch. So with this, if you'll keep looking here, the content that was there that was added as a part of Bangalore branch, which was nothing but the address.txt, this file should appear as soon as we do a merge. All right, so it happened quickly, and you would see this address.txt that is here. So if you see, let's check the contents in terms of the git log. All right, so there was only one branch that we had earlier, which had only one commit. Right now, we are at this Bangalore branch commit, which was there as a part of the Bangalore branch commit. So with this change, let me push this change onto the server as well. Git push origin master. Okay, those changes were pushed to the server. And now, if at all I do a refresh out here, okay, I'm in 2 branches. The branches is master. Even if I'm in master branch, I should see this address.txt that is there. Even if I'm in the Bangalore branch, the content is all same because we have merged these 2 branches. Now that I've merged this branch, I don't need this branch anymore. So I would go ahead and delete this locally as well as push it onto the server so that it gets deleted from the server as well. So delete branch locally. The command is git branch -d and the name of the branch. Only thing you need to ensure is that you should not be currently on that branch which you're trying to delete. So I would say git branch, and I'm presently in the master branch, so I can go ahead and delete the other branch. So git branch -d Bangalore branch. All right, this got rid of our Bangalore branch locally. If at all I do a git branch -v, it shows there's only one branch as of now. However, this branch would still exist on the server because server doesn't know anything about the changes that we have done. We need to specifically push our changes onto the server. Okay, there are 2 branches still here. So let me go ahead and push these changes so that the branch gets deleted from the server as well. The command to do that is git push origin -delete and the name of the branch. All right, so this went ahead and deleted the branch from the server. Let's check that. Okay, if you see now, there's only one branch. These are the basic steps that you would need to know before you work with any of the branches within Git. And as I said before, the branches are very, very inexpensive in Git. Go ahead and create any number of branches that you want, but just ensure that once you create your branch, finish off your task, and once you finish off your task, go ahead and delete the branch. And before you delete the branch, please ensure that you merge in the branches so that you get in or take in the work that was done as a part of that particular branch. To summarize, the Git branching commands are as follows. To create a new branch, you issue a command git branch, the name of the branch, and this would automatically spin off or create a new branch from the existing branch from where you issue this command. If you are on the master branch and if you execute this command git branch new underscore branch, it creates a new underscore branch from the master branch. Once you create a new branch, in order to get into this branch, you would type in git checkout, the name of the branch. This would automatically switch the file system snapshot between different branches. Now the branches that are created are by default created on the local repository. In case you want to push any specific branch onto the server, you would have to issue a command git push -u origin and the name of the branch. So this will ensure that the contents of the new branch are pushed onto the server. At any time, if you want to list out all existing branches on your local repositories, the command would be git branch -av. Assuming that you did all your work in a new branch and you're happy with the changes, you would want to bring back those changes into the master branch. The command to merge the contents of any new branch into a master branch would be git merge and the name of the branch. This would automatically merge the branch contents that you specified into the branch on which you currently reside. If at all you're on the master branch and if you issue a command git merge new underscore branch, this would merge the contents of the new branch onto the master branch. So once you merge the contents of any branch, you would possibly want to go ahead and delete this branch. So the command to delete those branch locally is git branch -D and the name of the branch. This again would delete the branch locally. In order to make this change on the server, which is in order to remove this branch from the server, the command to do that is git push origin -delete and the name of the branch. This would also delete the branch that you created on the server.
In this session, we're going to cover the topic of what is Angular. I'm sure all of you use mobile and web applications. Be it from social media to healthcare, e-commerce and net banking, these apps are used by billions of people across the globe. Now, the main reason we use these apps is that they offer seamless user experience and interface. But how are they developed to provide such reliability? One of the frameworks that is widely used to build such robust apps is Angular. So let's dive into the session now. So here is a list of topics that we're going to be covering. First up, we'll see why Angular was introduced. Then what is Angular? Features of Angular, Angular architecture, advantages and limitations of Angular, the learning curve of Angular, and finally we'll look at some of the companies that deploy Angular. So without further delay, let's begin. Why Angular? Now, JavaScript is the most commonly used client-side scripting language. It is written into HTML documents, enabling interactions with web pages in many unique ways. So, as a relatively easy to learn language with almost pervasive support, it is exceptionally well suited to develop modern applications. But the question arises, is JavaScript ideal for developing single-page applications that require modularity, testability, and other features? Perhaps not. However, we have a variety of frameworks and libraries designed to help us with such things. With respect to front-end development, Angular and JavaScript together bring in structure and consistency to your web applications and also provide scalability and maintainability. And Angular is specifically developed for single-page applications. So now the question arises, what exactly is Angular? Angular is an open-source JavaScript framework written completely in TypeScript. Now, it was primarily aimed to develop single-page applications and is maintained by Google. Angular as a framework provides a few advantages while also providing a standard structure for developers. It is designed for web, desktop, and mobile platforms. Now, if you have a doubt here as to what exactly single-page applications are, let me help you with that. Now, these single-page applications are basically applications that get loaded just once. So the main page gets loaded onto your browser. So any further interactions does not lead to loading of subsequent pages. Anything that has to be done further is just an addition to the already loaded page. So these single-page applications are primarily developed using Angular. Moving ahead, let's look at the features of Angular. We have 4 features that we're going to be discussing. We have the document object model, TypeScript, data binding, and testing. Now let's look at them one by one. Now the document object model treats an XML or an HTML document as a tree structure. Now here every node in the tree structure defines an object representing a part of your document. Angular uses the regular DOM. Now let's suppose you've made 10 updates on a single HTML page. So every time you make a change, the corresponding DOM or the tree structure needs to be updated. Now Angular updates the entire tree structure of HTML tags. Moving on to our next feature, we have TypeScript. Now TypeScript defines a set of types to JavaScript, which helps you write JavaScript that is easier to understand. Now all the TypeScript code compiles down to basic JavaScript that can run smoothly on any platform. Now TypeScript is not mandatory for developing an Angular application, but it is highly recommended. The main reason it's highly recommended is that it offers better syntactic structure while making the code base easier to understand and maintain. Now TypeScript can be installed as an npm package. Now to do that, you just have to run the command npm install -g TypeScript on your command prompt. Next up is data binding. Now data binding is a process that allows you to manipulate web page elements using the web browser. Now it mainly employs dynamic HTML and does not require complex scripting or programming. It is used in web pages that include interactive components like calculators, tutorials, games, etc. Now incremental display of a web page makes data binding extremely convenient when pages contain a large amount of data. When it comes to Angular, it uses two-way data binding. So any changes made in the UI element is reflected in the corresponding model state. And conversely, any changes made in the model state are reflected onto the UI state. Now, this allows the framework to connect the DOM to the model data via the controller. The last feature we're discussing is testing. Angular uses Jasmine to run its various tests. The Jasmine framework allows various functionalities to write different kinds of test cases. Karma is a task runner for the tests that use a configuration file to set the startup, reporters, and testing framework. So with that, we've covered the features of Angular. So let's go ahead and understand the architecture of Angular. Now, Angular is a full-fledged MVC framework. It provides a strong opinion on how the application should be structured and offers bidirectional data flow and updates the real DOM. MVC, short for Model View Controller, is an architectural pattern that separates the application layer into model, view, and controller. Now, model here relates to all the data-related logic. View, on the other hand, is used for UI logic of the application. And controller is the brain of the setup. Now, it is an interface between the model and view. Moving on, let's look at the advantages of Angular. First up, we have custom components. Angular allows you to build your own components that can pack functionality along with rendering logic into reusable pieces. Data binding. As discussed, Angular allows you to effortlessly move your data from your JavaScript code to the view and react to user events without having to write any code yourself. Dependency injection. Angular allows you to write modular services and have them injected wherever they are needed. This greatly improves the testability and reusability of the same. Don't worry if you can't wrap your head around these topics. We're going to discuss them further in the coming videos. Next advantage is testing. Angular has been built from the ground up with testability in mind. You can literally test every part of your application. Comprehensive. Angular is a full-fledged framework and provides out-of-the-box solutions for server communication, routing, and more. Lastly, we have excellent browser compatibility. Angular is cross-platform and browser compatible. An Angular application can typically run on all browsers, be it Chrome, Firefox, Safari, and platforms like Windows, macOS, and Linux. Now, many versions of Angular have been released ever since its inception. All of these versions have added to the efficient working of the framework. Now, here are the different versions released. First up was Angular 1. It was built on JavaScript and completely based on controllers. Next release was Angular 2. Now, this incorporated the component-based approach. wherein the entire UI was divided into several components and lastly integrated to give the final logic. Next was Angular 4. It included router updation. Angular CLI or Command Line Interface 1.0 was introduced, however not deployed. In this release, the Angular CLI was optimized and commands like ng-update and ng-add were added. In the Angular 7 release, prompts were introduced which provided tips in CLI about the functions being used. In Angular 8, IV renderer and Bazel were introduced. And finally, the most recent release was Angular 9. Now this came with the better framework and Angular material. Now this completely switched to the IV renderer as a default compiler. Now that we've learned about the pros of using Angular, let's look at some of the limitations of Angular. First up is a steep learning curve. Now since Angular is a complete full-fledged framework, it becomes difficult for learners to begin with. You need to be acquainted with simple topics and then move on to more advanced topics to become proficient in this language. Next up is limited SEO options. Now, Angular offers limited SEO options and poor accessibility to search engine crawlers. It's verbose and complex. Now, a common issue faced by the Angular community is the verbosity of the framework. It also poses to be complex compared to other front-end tools. And lastly, migration. Now, one of the drawbacks of Angular is poor migration. Now, it becomes difficult to port legacy code to Angular-style architecture. Also, with each new release, it is painful to upgrade and a lot of them are not backward compatible. Next up, let's look at the Angular learning curve. Now, if you wish to learn Angular, you need to be acquainted with basic topics in Angular. Some of them are directives, modules, decorators, components, services, dependency injection, pipes, and templates. Now, once you've mastered your basics, you will want to go and understand more advanced topics such as change detection, zones, AOT compilation, and rx.js. However, the learning curve of Angular is clear-cut. In the beginning, it could be a little intimidating, but once you start using the tool, it becomes way more easier to comprehend and understand what is going on. And lastly, let's look at some of the companies that use Angular today. Many top-tier companies like Nike, Forbes, Google, HBO, Sony, Upwork, among others, readily deploy Angular. So moving on, let's look at the prerequisites for Angular. First up, we have Node.js. Angular uses Node.js as its base for a large part of its build environment. So as a result, to get started with Angular, you will need to have Node.js installed on your environment. So head to their official website and download the latest release for your corresponding operating system. Next up is the Angular CLI. Now this command line interface is a tool that makes it easier to bootstrap and develop your Angular applications. Now to install the latest version, run the command npm install-g at angular/CLI. You gotta run this command on your command prompt. And finally, to confirm installation, check for its version. Now the next thing that you will need is an IDE or a text editor to type your code. Now there are several IDEs that you can choose from. But in this series, we've used VS Code throughout. So it is available on all platforms. So go ahead and download it if you haven't already. Now moving on to the final part is the demo. Now that you have a basic understanding of Angular and its prerequisites, I think you're ready to create your first Angular application. So let's head to our VS Code and begin. Here, I've created a folder called Angular on my desktop and opened it on my Visual Studio Code. So to create your app, you need to open the terminal. Just go here and select New Terminal. And now type in the command ng new and provide the name for your app. So I'm just going to say Hello World. So now this is going to create. Just say yes. So basically what happens is that when you run the command, it will automatically generate a skeleton application under the folder that is Hello World in our case. and it includes a bunch of files and installs all the necessary dependencies for the Angular application. So this could take a while. So once you've created your application, to run it, first change the directory. So let's say cd hello world. And now use the command ng serve. Now once it's compiled, you need to go to your browser and type in localhost 4200. And once you do that, you can see your UI. You can see that the application has been loaded onto your browser and it says Hello World app is running. So this is how you create your application. So let's go back to our VS Code. Now as you can see here, there are many files and folders that are created, right? So let's look at a few of them. Of course, we can't explain everything, but I'll brush through a few of them. So the first main component is basically the root component. Now the root component here is the index.html. So here, if you open the file and see, it's a very small crisp code, right? But the most important thing in the file is this app root element. So what this does is it's basically the marker for loading your application code. So this is extremely important. So the next important file is the main.ts. Now this is the part of the bootstrapping piece. Alright, so the index.html file is responsible for deciding which files are to be loaded, correct? The main.ts file, on the other hand, identifies which Angular module is to be loaded when the application starts. So this is just a brief explanation as to what they are doing. Next, we have the app folder. Now here, we have the app.module.ts file. Now this application module file can be thought of as the code configuration of your application. So here's where the source code starts from. And moving on, we have the app.component.ts. So these are all TypeScript files, hence the extension TS. Now this file basically is the root component of your application. And then we have the HTML file for the same, which defines the appearance of what you can see on your browser. So let me just change the message that is being displayed. So I'll say, hey, welcome to this Angular tutorial. So let's save this. And when we go back to our browser, we can see the message, hey, welcome to this Angular tutorial being displayed. So like this, we can make a simple change and then it gets rendered onto your browser. So this was just a brief explanation of what happens in the background of your application. First, we'll get acquainted to what exactly Angular components are. Then I'll help you create an Angular component by showing a quick demo. And lastly, we'll learn about component decorator metadata. But before we begin, make sure to subscribe to our channel if you love watching new and interesting technology videos. Also, hit the bell icon to never miss an update. So what exactly are Angular components? Now I'm sure everybody uses web applications. And one of the most widely used applications is Gmail, correct? Now to help you understand what components are, consider them as Lego blocks. Now they basically are combined together to form the final application. So in this case, here we have the logo component, then you have a sign-in component, an image component, and then a create account component. Now all of these components generally don't affect the working of each other. But however, when embedded, they define the UI of your application. So I hope you understood what components are. So to go ahead, let's discuss some of its common features. Now firstly, they are the building blocks of an application. Generally, you have a root component, which is basically the app component, and then it branches out into other components, creating a hierarchy. And these components are a subset of directives. Now don't worry about what directives are because we'll cover them later on in the series. But to give you an idea, there are three types of directives. You have the structural directives, the attribute directives, and the component directives. Only one component can be instantiated per element in a template. Now components are typically custom HTML elements, and each of these elements can instantiate only one component. Now don't worry, you'll understand this better when I show you the demo. Nextly, a TypeScript class is used to create a component. Now this class is then decorated with the @component decorator. Now the decorator accepts a metadata object that gives information about the component. Now a component must belong to the ng module in order for it to be usable by another component or application. And finally, components control their runtime behavior by implementing lifecycle hooks. So this was just a brief introduction to what Angular components are. Now you will only be able to understand the working of components when I show it to you practically. So let's head over to our Visual Studio Code. Now here, back in my VS Code, I've created a folder called Angular Demo, within which I've created an Angular application called Demo Components. Once executed, the browser looks something like this. So if you haven't watched our previous video on getting started with Angular, that is Angular Hello World, I highly suggest you go through that video first. It helps you create your first Angular application. So now let's go ahead and create our first component. Now the command used to create our component is ng-gc and your component name. Once executed, it creates 4 different files. Now let's just see how this works on our VS Code. Now what you can do is head to your terminal and type in the command ng-gc and provide a name for your component. For example, I'm going to just call my component text component. Alright. So what it does is that it creates 4 different files. You can see you have 4 different files that have been created, and finally it updates the file that is app.module.ts, indicating that this new component has been created. So here in your source folder, within which there's an app folder, and again here you can see that your 4 different files have been created. First is the HTML file, wherein you can define all the code that you want for your component. Next you have the CSS file for your styling. Then you have the .ts file, which includes the component decorator. And finally you have spec.ts, which is basically a unit test file. Alright. And then in your app.module.ts, you can observe that the component that you've created, that is text component, has been imported. That is what the message conveys here. Alright, now let's go back to our app.component.html. Now this basically has all the code for your application. So let me just get rid of it. And I'm just going to display a basic heading saying hello, welcome. Alright, so let me save it. And if you go ahead and look at your browser, hello, welcome message is displayed. Now let's go back to our component.html file. And here, let me provide a message. Let me say H3. And let me display a message saying, welcome to this tutorial on Angular components. Alright. Now in your text component.ts file, which is your TypeScript file, the selector mentioned here is app-text component. Now go ahead and copy this. And in your final component.html, go ahead and create your custom HTML tag with the selector that you just copied. Now this indicates that the component that you just created, that is the text component, is being incorporated in the final render. So what happens is that whatever is defined in the component.html file is also being rendered in your final output. So when I save this, let's go ahead and check our browser. You can see that the message welcome to this tutorial on Angular components is displayed. So this was a simple creation of a component. Now for this, let's give it some styling. So here, go to your .css file and provide some styling. Say for example here, I just say text align. And let me say center. And also in my app.component.cs, I'm going to give the same thing. I'll say h1 text align is center. Alright, so let me save this. And there we go. Now we can also create multiple components and define the tags in the app component. Now the components are executed sequentially. So now let's create another component just to give you a brief insight into it. let's say ngGC image component. Now here I'm going to be adding the Simplilearn logo. So I'll show you how that works. Now you can see that a new component has been created with 4 files again. So in my assets folder here, I've added the logo. So what I can do is back in my HTML file, I can go ahead and create an image tag. So first, let me just display another message here just to avoid any confusion. And let me say this is the image component. And then let me say image source equals, so the source is basically assets / logo.png and class equals center. Alright, so you can also head to your CSS file and provide any sort of styling that you need. So let me just say text align to be center, and then let's create a styling for the image, and here I mentioned the code for the image. So let's save this, and from the .cs file let's copy the selector and create a custom HTML tag in our final component.html file. So there we go. Let's save this and check the output. And there we go. First, the hello welcome message is displayed. Next, you have the message displayed from the first component, and then you have the second component. So this is how you can create your own components, and don't forget to incorporate these selectors into your final HTML file. So moving on to our next topic, component decorator metadata. Now, as mentioned earlier, the @component decorator accepts a metadata object that provides information about the component. Correct? Here is a list of properties of the metadata object. First up is the selector. Now, basically, the selector is a CSS selector that identifies this particular component in a template. Now, this corresponds to the HTML tag that is included in the parent component. You can create your own HTML tag. However, the same has to be included in the parent component. So to help you understand that better, let's head back to our VS Code and say, for example, in our text component here, the selector says text component, correct? For the time being, let's change it to say n component. All right. Now, when you save it and look at the browser, the message is not displayed. So what we can do is you can copy this selector and then include this here. And now you can see that the same component has been rendered onto your output. Alright, so the selector plays a crucial role in that. Next up, we have the template. Now, a template is an inline defined template for the view. Now, the template can be used to provide some particular markup. The markup could typically include some headings or paragraphs that are displayed on the UI. Next up, we have template URL. Now, it is the URL for the external file containing the template for the view. So here you can see, this is basically the external file that contains the template for the view. Next up, you have styles. Now, these are also inline defined styles that can be applied to the components view. So any code that you provide in the .css file can also be included here. Next, you have the style URLs. Now, this is a list of URLs to your style sheets that are applied on your components view. Next up, you have providers. Now, this is again an array where certain services can be registered for your component. Lastly, we have animations. As the name suggests, these are animations that can be listed for your components. First, we'll understand what exactly dependency injection is. Then we'll understand the demerit or the drawback of not using dependency injection. Then we'll understand dependency injection as a design pattern. And finally, I'll help you understand the entire concept with the help of a demo. So let's begin. What exactly is dependency injection? So let's consider this. I'm sure you're aware that Angular uses the concept of components. The entire UI of the application is divided into several components. Now, what if all of these components perform similar tasks, be it accessing the database, rendering images, etc.? Now, instead of writing the same piece of code for every component, you could write the code once and then perhaps inject the same code into every component. Now, this is supported by dependency injection. Now, to give you a better example, consider two classes A and B. Now, let's assume that A uses the objects of class B, and normally in object-oriented programming, an instance of class B is created so that A can access its objects. But using dependency injection, we move the creation and binding of dependent objects outside of the class that depend on them. So dependency injection or DI keeps the code more flexible, testable, and mutable. Also, classes can inherit external logic without having to create on its own. And lastly, DI benefits directives, pipes, and components. Next up, let's have a look at the drawback of not using dependency injection. Now let's consider class postal details that is dependent on the number and the address class. In the postal details class, the constructor creates copies of the number and address. So when you instantiate a new postal details class, the constructor instantiates a unique number and address. Now, although this looks simple, there's a problem with this code. Let's assume that the number and address class constructors now accept parameters. When we change the numbers class, the postal details class gets broken. Now, to overcome this, what we need to do is we need to pass parameter to the number constructor. So this applies to address as well. The first drawback of using this traditional method is that the code is not very flexible. Anytime the dependencies change, the postal details class needs to be changed as well. And the second drawback is that the code is not suitable for testing. Once you instantiate the new postal details class, you get the same number and address. Even if you change the number and address classes every time, what if these classes are in turn dependent on other classes? Then it's going to be a chain reaction. So to overcome this, we make use of dependency injection. Now let's look at DI as a pattern. Dependency injection, as you all know, is a coding pattern where a class receives its dependencies from an external source rather than creating them on its own. So here in the above example, we have moved the definition of dependencies from inside the constructor to the constructor's parameters. So the postal details class doesn't create the dependencies anymore. It just consumes them. So the postal dependencies class doesn't create the dependencies anymore. So with that, we overcome the drawbacks of not using DI. So now that you know what exactly dependency injection is and how vital it is, let's look at a simple demonstration to understand the concept better. Now, services, classes, modules, components, all of these are benefactors of dependency injection. So in the demo, I'm going to be showing how dependency injection can be used with the help of services and injecting these services into classes. So the main thought behind this is normally components are used to ensure just a good user experience. These components do not generally execute tasks. So to execute these tasks, we make use of services. So a component can delegate tasks like fetching data from the server, any network related issues, etc. to a particular service. And these services can be made available to components. With the same thought, what I'm going to be doing is I'll be creating a service that performs the task of displaying an employee list. Later, we're going to inject this service into the class using dependency injection. So let's head to our Visual Studio Code for the demonstration. Alright, so as discussed, I'll have to first create a component that displays a button for the employee, and then I have to create a service class and inject it into my component. Now this service holds the employee details such as name, employee ID, email ID, etc. So first, let's go ahead and create a component. So here, let me just type ngGC, and the name of the component I'm providing is empinfo.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Alright, so as you can see here in my app folder, I have the component. with 4 different files. Alright, so the next thing we have to do is we have to create a service. So to create that, we make use of the command nggs. You can either give s or service, and the service name I'm providing is records. So let me just say records here. Alright, here you can see 2 files are created. There is a spec.ts file and the .ts file. Alright, so now the service contains all the employee data that needs to be displayed. Right, so let's go ahead and write the data. So first we're going to make use of 3 arrays. I'm going to be displaying employee records for 3 employees. So I'll have to create 3 arrays and provide certain information. So let's go ahead and do that. Alright, so the array I'm creating is called info1 for the first employee. And I'm going to be passing information like name, employee ID, and the email ID. So the array is of type string, and within which, let me just mention the details. I'm giving random information. I'm just saying Adam Taylor and some random employee ID, and let's say at@abc.net. Alright, so I'm going to be creating 3 records, so I'll just copy the same thing and paste for the rest too. Let's just change here, provide a different name here. And same for the last one. And let me change the name of the array as well. Alright, so with the agenda to retrieve this data in our component, we make use of the method for the same, right? So this method returns the employee data. So let's go ahead and create this method. I'm going to call it getInfo, and then just say string, and then this will just return this.info1. Alright, I'm going to be calling it getInfo1 for better understanding. Same for the rest too as well. I'm just going to return different arrays here. Alright, and lastly info3. Alright. Now in order to retrieve this information in our component, we need 3 more arrays, right? 3 more arrays that will receive this data. Let's go back to our component.ts file here and then type in the following code. So I've created 3 arrays again. Info received 1, 2 and 3. Now what we need to do is we have to accept the information that is being sent from the service, correct? Now as I mentioned, services are implemented with the help of dependency injection. So what we need to do is we'll have to first import the service into the component.ts file. The key reason behind doing this is that when Angular creates this component, an instance of the service class is also made to perform the necessary tasks. Correct? So let's go ahead and just import it here. So I'll say import records service from and let's say records.service. Alright, and what we have to do next is that we must also declare this instance that is being created in the providers array of the component. Alright, so let's just say providers and then say records service. Alright, now we've created the instance of this class, right? However, to access this instance, an object is also created So this object will in turn access the methods and variables of the service class. So for that we have to create another object. So let's do that here in our constructor method. Let's say constructor private, and the object I'm creating is called our service. You can give a name of your choice, and then I'm going to just say records service. Alright, now this object will help me retrieve data from the service. So let's go ahead and use this in order to get the employee details. Alright, so I've created 3 different methods here: get info from service class 2, 1 and 3. And these methods will retrieve the data and add it to our array here, that is info received. Alright, and lastly we'll have to create an unordered list in our HTML file here. We haven't added anything, so let me get rid of this. So now I have to create 3 different buttons for 3 different employees, and when the user clicks on the button, the data is retrieved from the service and then displayed on the UI, right? So as you can see, I've created buttons for 3 different employees, and then I've made use of a bootstrap class called list group info, and then I've interpolated info which displays the contents of the info variable. Alright, now in order to call the methods in the .ts file, we have to bind them with the button. So since it is bound with the click event, every time you click on the button, the information is displayed. So now the last thing we have to do is we'll have to create a custom HTML tag for the component and then add it to the main component. So let's just do that. Let me copy this here. And then in my app component.html, let me get rid of this. And then let me just create this. I've just created the custom HTML tag for my component. And now just to beautify the code, I'll write a heading. And let's say employee details. And then I'll also add the Simplilearn logo, say image source. I've added the image here, so let me just say logo.png. I've also added some styling to it. Alright. So now let me just save this and have a look at the browser. So here we go. We have the logo here and then employee details heading. And then we have 3 different buttons created, that is employee 1, 2 and 3. And when I click on it, the information of the employee is displayed, the name, the ID and their email address. So yeah, so this is how you can make use of dependency injection and inject a service class into a component. Dependency injection plays a crucial role in Angular. We'll understand what Angular forms are. Then we'll look at the different types of form building supported by Angular. Next up, we'll get acquainted with features like form control and group control. And we'll learn all of this with the help of a simple demo. So without further ado, let's begin. So what exactly are Angular forms? Now I'm sure every application that you use comes with certain amount of form filling, correct? Be it your login credentials or your sign up forms or any sort of registration forms, etc. So forms are an integral part of a web application. You need forms to update your profile or to enter sensitive information, or also to perform any sort of data related tasks. So now let's look at the different types of form building supported by Angular. First up, Angular supports 2 types of form building. First, you have the template driven approach, and second, you have the reactive approach. Now let's look at them one by one. So talking about template driven approach, in this method, the conventional form tag is used to create forms. So Angular automatically interprets and creates a form object with the help of the directives. Now controls can be added to the form using the ng-model tag. Now multiple controls can be grouped using the ng control group module. So it basically uses several module classes to provide controls. Now if you don't get this, don't worry, you'll understand better when I'm showing you the demo. Next up is JSON values. So a form value can be generated using the form.value object. Form data is exported as JSON values when the submit method is called. Lastly, basic HTML validations can be used to validate the form fields. In the case of custom validations, directives can be used. So arguably, this method is the simplest way to create an Angular form. So moving on to reactive approach. Now this approach is the programming paradigm revolving around data flows and propagation of change. Now with reactive forms, the component directly manages the data flows between the form controls and the data models. Now reactive forms are code-driven unlike template-driven approach. Reactive forms eliminate the anti-pattern of updating the data model via two-way data binding. So it does not use two-way data binding. And typically a reactive form control creation is synchronous and can be unit tested with synchronous programming techniques. So now let's go ahead and look at form control and form group. So consider a typical form consisting of fields like name, age, and location. Now a form control is basically a class that enables validation of these fields. For each input field, an instance of this class is created. Now these instances help check the values of the field and see if they're either touched, untouched, dirty, pristine, valid, invalid, and so on. So this allows you to check every field for the value. It makes it easier to understand which field's value is invalid or which field has not been entered, etc. Now moving on to form group. So a form group class represents a group of controls. A form can have multiple group controls. The form group returns true if all the controls are valid and provides validation errors if there are any. So I hope this was clear. So moving ahead, let's look at the demo to explain all of these features. I'm sure it will become extremely clear once you look at the demo. So for that, let's head to our VS Code. So back in my VS Code, I've created a component called form component, and I've also included the Simplilearn logo just to beautify the appearance. So once you execute the code, this is what you're going to see on your browser. So you just have the logo at the moment. The first thing we need to do is we'll have to import the forms module. Alright. So, but before we begin, let me tell you what the use case is. So we're going to be creating a user registration form, which is going to include 4 fields. That is the first name, last name, email ID, and a password. Alright. So now let me show you how to import the forms module. So in your main app.module.ts file, you'll have to import forms module from Angular Forms. Alright. And then in your imports, you'll have to just call it here. Alright, so this is just a simple step. And now once you're done with that, let's go ahead and start our form creation. So here in my component.html, let's enclose the entire form within a div tag. So here, let me say div class is a container within which let me just have one heading which says user registration. Alright, and now let's go ahead and create our form. So first let me just say form. Now I'm going to create a div class for every field. So say div class equals form group. I'll explain it to you a little later. Now first let's create a label. So label tag for, basically it's the first name. So let me just say first name. And the tag will basically have first name again. Alright, and let me just break the line. Next we have the field. So let's say input. Type is text. Name is first name. And we have a class which is the form control class. Alright. So this we'll have to do for all the other fields. So let me just copy this and paste it like 4 times. I'll also add the tag pre for spacing. Let's do that here. And finally, we'll have the button. So let's just add that here with a type submit. And let's just say submit on the button. So now let's go ahead and change these values here. So here let me just change it to last name. Here as well. And here as well. And in this case it is going to be email. So let me just change it here. And finally we have passwords. So let's add that here. Alright, so let's save this and just have a look at our browser. So there we go. We have our user registration form ready, but I would like to align it to the center. So let me just do that. So here in my CSS file, I'm just going to align all the div tags to the center and the label tag to the left. So let me save this and look at the browser now. And there we go. We have our registration form with a logo. So this is how you create a simple form. Now we'll have to add a directive called ngModel. Now this directive, when added into the input tag, will provide form controls to every input field. Alright, so here let's just go ahead and say ngModel. That is it. So let me just copy this and paste it for every other field. Alright, let me save this. And back in my browser, let me inspect. And here you can see different types of classes like ngUntouched, ngPristine, ngValid are added. Right? So this indicates that Angular has recognized the form tag and it has added these classes to the form as well as all the fields. So this is achieved when you add the ngModel directive in your input tag. Now, back in my VS Code. Now every form has an output property attached to it called ngSubmit. Alright, so this property can be bound within a method called the submit method. So once submitted, this method is called. Right? So once we click on the submit button, this method has to be called. So to include that, we'll have to just say form ngSubmit equals submit. Alright. So now we have to define the submit method in our component.ts file. So here, let me just go to our component.ts file and let me just get rid of unnecessary code here. And let's define a function called submit. And then here, let me just console log form submitted. Alright, so let me just get rid of this as well. It's unnecessary here. Let's save this. So what it means is that every time you click on the submit button, this method is called. Alright, so let's just have a look at the browser. So first let's go to our console. And when I click on submit, it says form submitted. Alright. So the next crucial step is to generate JavaScript representation. Now we'll have to make use of another directive called ngForm that is assigned to a template variable. Okay, so this JavaScript representation helps with validating all the fields. So I'll help you understand that better. So back in our HTML file, let's just create a variable first. Let's call it login. Alright, and say ngForm. Okay, now the ngForm object includes the JavaScript representation. So now while you're calling the submit method, you're going to pass login as a parameter. So let's just say login here. And in my TS file, again, let's just say login. And along with it, I want login to be displayed. So I say login again. So now let's save this. And if you have a look at the browser, let's click on submit. And now here you can see the JavaScript representation. So within form, I can check for email or say first name. And here for this field first name, you can see different properties attached. You can see invalid. Is it invalid or is it untouched, which is true, or are there any errors? So this basically gives you all information about the particular field. So we can make use of this feature to validate the information. So we're going to learn about that in our next segment. Moving on to form validation, one way to ensure that incorrect fields are not submitted is by disabling the submit button. Correct? Now apart from this, you can also specify certain properties in your input tag for the corresponding input field. Now let's say that the fields can't be empty and the form only accepts names with the minimum length of 2 and the maximum length of 7. Alright, so here in my input tag, I just mention required, meaning this field cannot be empty, and min length to 2 and max length to say 7. Alright, so to check this, let's go to our browser, and here let me submit the form without filling the first name, and evidently there has to be an error. So when I submit it and I look here within forms and here controls, and my first name, you can see that an error is shown. Here it says required equals true. That means that there is one error. Now you can make use of these form control objects. You can leverage form control objects to ensure field validation and display a message whenever an error occurs. Right? So to do that, you need to access these objects like errors or invalid or touched. All of these properties or objects need to be accessed. For that, we'll have to create a template variable. And then this variable is assigned to this object. So back in our VS Code, let's create a variable. Let me call it name. And let's say ng model. Alright. Here the variable name receives the control object. So here back in my browser, when I submit again without the first name, you can see that the invalid property is set to true. Correct? So this helps us use this property to alert the user with the help of a simple if logic. So back in my VS Code. Let me create another div tag within which I mention ngIf, within which I'm going to use a simple if logic. So let's say ngIf name, which is our template variable, name dot touched and name dot invalid is true, right? Then I'm going to alert. So I'm going to make use of an alert here. Let's say alert danger. Alright. So in my CSS file, I'll have to mention the simple styling for alert. So here, let me just say, so we're going to have the background color red for danger, alright? And here, I'm going to display the message invalid in bold. So now, let's go back to our browser and check it. So let me proceed without entering the last name. It says invalid here. So this was a simple demonstration to show you form validation. Of course, you can modify the code depending on your requirement. Say suppose the length of the first name is too short, then you can alert the user with a different message. Or suppose they have missed out on filling a form field, then you can again alert the user. So you can basically make use of the nested if condition, right? Now just to help you understand that better, let me just show it to you. Now back in my HTML file, instead of invalid, let me have another tag, a paragraph tag, within which I make use of ngIf again. Now ngIf name.errors.required is true. Then I display the message first name required. Alright. And if the length of the first name is not 2, now if the length of the first name is less than 2, then I'm going to display another message. So let me just say name.errors.minLength. If this is true, then I'm going to say sorry, short first name. Alright, so let's save this and have a look at the browser. When I proceed without providing the name, it says first name required. But when I type in one character, it says sorry, short first name. But if I type in another character, it accepts. So I hope this made you understand how form validation works. So this was just a simple demonstration again. Now I highly recommend you explore these properties and play around with these objects. Trust me, it's really fun. So I hope this tutorial helped you out. I'm sure you all know that an Angular app is divided into several components. For example, you have the logo component, you have the sign-in component, an image component, and say a create account component. Now these components are standalone and each of them represents a part of the user interface. Now imagine if all of these components performed common tasks, for example, accessing the database or rendering images on the view, tasks like those. Now instead of having to write the code for every component, you can just make use of Angular services. Now the service can be written once and then injected into all of these components. Now a service could be a function, it could be a variable, or a feature that an application needs. So the main use of a service is to write code once and avoid rewriting of it. Now the same code can be injected into several components that make use of this particular service. But what are Angular services? So normally components are used to ensure a good user experience. Now that is the extent of it. Components make sure that whatever is being rendered onto the screen is right and pristine. But in order to execute tasks, we make use of services, and this approach is ideal. So a component can basically delegate tasks like fetching data from the server, validating user input, or logging directly to the console to a particular service. And these tasks can be made available to any component in the app. So now let's talk about a few features of Angular services. Now typically an Angular service is simply a TypeScript class with an @injectable decorator. This decorator tells Angular that the class is a service and can be injected into components that need that service. Now they can be used to share the same piece of code. They can also inject other services as dependencies. Now these services hold valuable business logic and can also be used to interact with the backend. Now for example, if you want to make AJAX calls, you can have methods to those calls in a service and then use it as a dependency in files. And as mentioned earlier, it can be used to share data among several components. In Angular, services are singleton, meaning that only a single instance of a service gets created and the same instance is used by each and every building block in the application. And finally, a service can be registered as a part of a module or it can be registered as a part of the component. Now to register it as a part of the component, you'll have to specify it in the provider's array of the module. I'm sure you'll understand the concept of services better if we look at a simple demo. So in the next section, we're going to look at a demo, but before that, let me tell you the use case. So basically in the demo, what we'll do is we'll create an employee details list. Say for example, you will have employee information like name, employee ID, and their email ID. We'll create a database of say 3 employees. And on the browser, when you click on the employee button, it displays the information about that particular employee. And at the end, we can also add information to the employee's details. So without delay, let's head to our VS Code and start learning Angular services hands-on. So here, first I've created a folder called demo_Angular, within which I've created a file called hello world. So this was previously used for a tutorial, so the name is just hello world, so don't get confused. However, when you look at the browser, I've written an initial code here, which is Angular services, and I have the Simplilearn logo. So back in my browser, this is what the UI looks like. So to understand the concept of Angular services, first let's go ahead and create a component. So here